Okay, guys, today we're looking at our second section in simplifying square roots. We're gonna be looking at adding and subtracting radicals. Okay, so when we do this, it's kind of just like the process of combining like terms. So if we were to look at number one here in our warm up and combine these like terms, we would combine everything that's like. So everything that has an x with it, we'd combine. Remember, like terms are the same variable to the same power. So this negative 3x and the 7x would combine to give me 4x, and this positive 4y and negative 9y would combine to give me negative 5y. Okay, this stuff should be fairly familiar to us at this point in the game. Okay, so this really process, remember, it matters about the variable and the power of that variable. Okay, for number two, I have 3x cubed minus 5x squared plus 8x plus 11x squared minus 3x. Okay, so there's a lot of x's in this one, but again, we just need to combine the ones that have the same variable, which they're all x, so we're good there, and the same power. Okay, so 3x cubed is the only x cubed, so it'll stay the same. This negative 5x squared plus 11x squared would give me 6x squared. Remember, they're both x squared, so I combine them. And then this 8x minus 3x would give me 5x. Okay, so the process that we're following here is, when it comes to radicals now, okay, is we're going to simplify each radical. We need to have those radicals simplified in order to be able to tell which ones are like terms and which ones aren't. Okay. Number two is to identify like radicals. Okay, we need the same index and same radicand. Remember, the index is that little number outside of the square root sign. Usually there's not a number. We just assume that it's 2, okay, if it's a regular square root sign. And the same radicand, which is the stuff under the square root sign, okay? Number three, we need to add like radicals. So we're going to add coefficients and keep the radical, okay? So for number one, we have 4 root 6 plus 7 root 6. We have the same index and the same radicand. So we're just going to add our coefficients here. And it's going to give me 4 plus 7, which is 11 root 6. Okay, so this root 6 almost acts like a variable in our warm-up. Okay, like our variables in this warm-up, when we combined our x's, for instance, that x didn't change. It was just x. But in this one, I'm just adding my coefficients, and my root 6 doesn't change. Okay, so it's kind of the same idea there, just now we're dealing with radicals rather than variables. Okay, for number two, I have 8 root 2 minus the square root of 2. Remember, if there's no number in front of this, it's assumed that it's a 1. So 8 minus 1 root 2. 8 minus 1 is, of course, 7 root 2. Okay, so it's kind of that same process of combining like terms, just now we're working with radicals. Sometimes we might have to simplify these radicals to start. Like number 3, I have the square root of 8 plus the square root of 162. If I were to simplify the square root of 8, I would get root 4 times root 2. This is that branching process that we talk about a lot. We're taking out our perfect square factors, okay? And 162, the square root of 162, 81 is a perfect square that goes into 162. So I would break that one apart like this. Okay, square root of 4, of course, is 2, root 2, plus the square root of 81 is 9, root 2. Okay, now I have the same radicand there, square root of 2, so I'm just going to add my coefficients. And 2 plus 9 is 11. So I get 11 root 2. Okay, so we're kind of combining the process of that first lesson we learned, excuse me, and combining like terms and getting to the point where we can simplify radicals and combine them if we need to, whether it's adding or subtracting. Okay, so same process with number 4. We need to simplify these radicals. Okay, perfect square that goes into 150 is 25, right? Think of quarters, think of money. Okay, so I have square root of 25 times the square root of 6. I'm breaking that apart. Minus 3, and then the square root of a perfect square that goes into 24, is 4 times 6. Okay, so of course I can simplify my perfect squares, square root of 25 and square root of 4, to 5 root 6 minus 3 times 2 root 6. Remember, this 3 is still out here, so I'm going to multiply. 3 times 2 is just 6. So I'd get 5 root 6 minus 6 root 6. And of course, now I have the same radicand. I have like terms, so I can subtract these to get negative 1 root 6 or just negative root 6. They're the same thing. Okay, so this process kind of can get extensive depending on how many actual things we need to simplify and combine. But at the end of the day, it's just simplifying radicals and combining like terms, okay? So for number 5, I have 3 root 20 plus 8 root 45. Again, I'm going to find the highest perfect square that goes into both 20 and 45. I'm going to break them apart. So I get 3 root 4 times the square root of 5 plus 8 root 9 times the square root of 5. Okay, square root of 4 is going to end up being 2. Square root of 9 is going to end up being 3. So I'm going to take 3 times 2 root 5 plus 8 times 3 root 5. I'm going to get 6 root 5 plus 24 root 5. Okay, so the simplifying process all the way down to this point right here, right after that line, it becomes, okay, do I have the same radicand? Can I combine these? And of course, we both have root 5, and we can, and 6 plus 24 is 30. So I get 30 root 5. Okay, so this process, these first two lines are just simplifying what we learned in the first section. Okay, everything after, can I combine them? Are they like terms? Okay, number 6, I have 5 root 8 plus 9 root 200 minus the square root of 32. Okay, so I'm going to have 3 separate things to simplify here. But that really shouldn't challenge us too bad. It might just take us a little longer, okay? So root 8 can split into root 4 times root 2. Now I know there's no dot in between root 4 and root 2 like there is over here, for instance, between root 4 and root 5. But again, if something's butted right up next to something in math, it's assumed to be multiplication. So I have 5 root 4 root 2 plus 9 times the square root of 100 times the square root of 2. Of course, 200, that's simplifying that. It's pulling out the highest perfect square factor minus the square root of 32. Of course, the highest perfect square that goes into 32 is 16. So I can simplify all my perfect squares, square root of 4, square root of 100, square root of 16, and I do that in that step. So 5 times 2 root 2 plus 9 times 10 root 2 minus 4 root 2. Okay, so I'm going to do my multiplication step here. I'm going to get 10 root 2 plus 90 root 2 minus 4 root 2. And I have like terms here. Now remember, when I have multiple things to evaluate here, I can just work left to right, okay? So what that looks like here is, if we were to do another step, I would do 10 root 2 plus 90 root 2 first, and I would get 100 root 2, and then 100 root 2 minus 4 root 2 would give me 96 root 2, okay? Remember, if I'm at the same level of my order of operations here and I have like terms, I can just work left to right. So I do 10 plus 90 first to get 100, then 100 minus 4 to get 96. Okay, and that is it for lesson 2 on adding and subtracting. So some big takeaways here, guys, are we need to know how to obviously simplify our radicals, and then identifying like terms and how they work with adding and subtracting.